Okay, now this is another topic, relationship between nearest neighbor distance, which is represented by d, radius of atom r smaller, and the edge length of the unit cell. Edge length is represented by the symbol small a. So relationship between nearest neighbor distance d, comma radius of atom r and the edge length a, small a, of the unit cell. So what is nearest neighbor distance? I mean, it is the distance between two closest particles. That distance is called nearest neighbor distance, and which is represented by d symbol. Then radius of atom, I mean the radius of particle, as the particles are spherical, so you can find out the radius, that represented by r symbol, and the edge length of the unit cell. Edge length means from one corner to another corner, what is the distance? That distance is called edge length, and that represented by a. Now you have to find out the relationship between the nearest neighbor distance, radius, and the edge length of the unit cell. And this relationship will be different for different types of unit cell. If it is simple cubic, you will get one relation. If it is face centered, you will get another relation, and if it is body centered, you will get another relation. So first time, for number one, we will determine for simple cubic, I mean primitive unit cell, for simple unit cell, for simple cubic. Now in case of simple cubic, as you know, when the unit cell is said to be simple cubic, when the particles are present only at the corners, then it is called simple unit cell or primitive unit cell. Suppose this is a cube and the particles are present only at the corners. You know, a cube contains 8 corners. So when the particles are present only at the corners, then the unit cell is called simple cubic. And these particles, suppose this is one corner, this is another corner, the particles are present like this. This is one corner particle, this is another corner particle, they are present like this. So I have shown only 2 corner particles. Similarly, this corner contain particle, this corner, every corner contain one particle. Then it is called simple cubic unit cell. Now suppose this center is represented by A, this center is represented by B. Since it is cubic, this from this A to B, this length is called the edge length. I mean from one corner to another corner, the length is called the edge length, and that edge length is represented by the symbol from one corner to another corner. This is represented by symbol A. And since the particles are spherical, this from this center to this point, this is called the radius of the atom, this is called radius of the atom. And since it is cubic, this edge length, this edge length, this edge length all are same, because you know it is said to be cubic when A equal B equal C. I mean all the edge lengths should be same. So all are, you have to consider as same distance from one corner to another corner. Now this is A, and this is said to be the nearest neighbor distance also D, because the particles are present only at the corners, and from one corner to another corner particle, that distance should be the nearest neighbor distance. And that is why it is very easy to find out the relation for simple cubic. You can write the nearest neighbor distance D is equal, you can write A. I mean D is equal, you can write AB according to diagram. I mean this AB is called nearest neighbor distance, and this is also called A. And in terms of radius, this is one R, this is another R, so A is equal, you can write twice R. I mean this is the relation between nearest neighbor distance, edge length, and the radius of the atom for simple cubic. It is very easy to find out for simple cubic. Directly you can find out the relation between nearest neighbor distance, edge length, and radius. But if you want to find out for face centered cubic, now I will determine for face centered cubic. When the unit cell is said to be face centered, when the particles are present at the corners and at the center of each faces. Now this is one of the unit cell. This is one of the unit cell. If it is face centered, the particles are present at the corners like this, and The center of faces contain one particle. All the faces contain one particle at the center. This is your back side face. This is your front side face. Like this the particles are present. Then it is called face center. See, I have drawn the particle in smaller size, but particles are attached with one another. If you consider the upper face, the particles are present like this. This is one particle. This is your face particle. This is your corner particle. This is your corner particle. Actually, one face contains the particle like this. This is one face of the cube. These four are present at the corners and this is present at the center of the faces. Now, here suppose this particle is represented by A, this particle is represented by B, I mean the center of the particle, and here the center is represented by symbol C. To find out the relation, you have to draw one diagonal through the face which is called face diagonal. I mean this AC is said to be face diagonal. I mean in this face, this point is A, this point is B, this point is C, and here I have drawn one diagonal like this AC. I mean this face is this one. Now, if you want to find out nearest neighbor distance means the distance between two closest particles. Here the corner and corner they have some gap, but the corner and face particle they are joined with each other. That is why the nearest neighbor will be the corner particle and the face particle only, not the corner particle. In case of simple cubic, the particles are present only at the corners. That's why nearest neighbor will be the corner distance. But here, since one particle is present at the center of faces, that's why the corner particle will somewhat separated from each other. So nearest neighbor will be the corner particle and the face particle. I mean half of AC you will get the nearest neighbor distance. This is your AC diagonal. Half of AC when you do, you will get the nearest neighbor distance. Edge length means the AB, BC, CD. If it is D, then it is said to be the edge length. I mean from one corner to another corner, that is called edge length. Now I will find out the relationship. Here you have got the nearest neighbor distance D is equal AC by 2. I mean AC का आधा करने से आपको nearest neighbor distance मिल जाएगा. Now what is AC you have that you have to find out. Since ABC is a triangle, from ABC it's a right angle, that's why you can write AC square is equal AB square plus BC square. So AB means what? AB means nothing, edge length. BC means what? That is also edge length. Corner to corner length is called edge length, and edge length is represented by symbol A. That's why you can write AB means A square, BC means you can write A. I mean A square plus A square, you will get twice A square. That means you can write AC is equal root 2A. So we have find out the value of AC. Now you can write therefore D is equal, as you have got AC by 2, so you put the value of AC root 2A divided by 2. Ultimately you will get A by root 2. So here the relation you have got between the nearest neighbor distance and the edge length. Now if you want to find out the relation with radius, so here you can write D means what? This is D. Half of AC from this to this point, this is called D, nearest neighbor distance. And D means this is one radius, this is one radius. I mean D means you can write twice R. Twice R is equal A by root 2. That means R is equal, you can write A by 2 root 2. So this is the relation between the radius, edge length and the nearest neighbor distance. These relations are very important. You should know about this relation. What is the relation between edge length and radius? What is the relation between radius and nearest neighbor distance? That relationship you should know. So if it is face centered cubic, the relation will be R is equal A by 2 root 2. But in case of simple cubic, you have got A is equal twice R. I mean R is equal A by 2. But here R is equal A by 2 root 2. So this is the process how to find out the relation between the radius and edge length of the particle. Similarly, you can find out the relation for body centered cubic also. If the unit cell is body centered, number 3, for body centered cubic, the unit cell is said to be body centered when the particles are present at the corners and at the center of the cube. I mean, at the center of the cube it contains one particle. Suppose this point is A, this point is B, C, and this is your D. When you draw a line from A to D, then it is called the body diagonal AD. And when you draw a line from A to C, it is called face diagonal, because you draw the diagonal through the face. Here, the nearest neighbor distance should be the corner particle and the body particle, because the corner 4 particles present above, 4 particles below, and at the middle position 1 particle is present, which is present at the center. So that is why nearest neighbor should be the corner particle and the body particle. And that is why if you want to find out D is equal, you have to write AD by 2. I mean, nearest neighbor distance is equal half of AD. I mean, half of the body diagonal. So you have to find out the AD from triangle ABC. You can write AC square is equal AB square plus BC square right angle. That means you can write A square plus A square. I mean, AC is equal, you can write root 2A. Similarly, from triangle ACD, you can write AD square is equal AC square plus CD square. AC means already you have got root 2A whole square, plus CD means nothing, edge length A square. Ultimately you can write twice A square plus A square, you will get thrice A square. I mean, AD is equal root 3A. Now AD is equal, you have got root 3A, so D is equal AD by 2. That means root 3A by 2. Again, you know, nearest neighbor distance is equal twice R. Nearest neighbor distance always equal twice R. I mean, when you consider 2 radius between 2 closest particle, that is called the nearest neighbor distance. So D is equal always twice R. So D you have got root 3A by 2. This is equal twice R, or you can write R is equal root 3A by 4. So this is the relation between the radius and the edge length for body centered unit cell. So this relation you have to learn in numerical, you have to use it. Thank you.